Plataforma, sir. 3. 1, 2, 3. Okay. And camera.
Okay, welcome. Today, we're going to be talking about quantitative structural models to assess credit risk on companies and individuals. The outline, basically, we're going to look at credit risk, default intensities, estimating default probability, first from the historical data, also from bond pricing. Then we're going to look at equity prices. We're going to estimate default probabilities from equity prices, which is kind of like what Meton did in his original work. Then we'll look at optimal portfolio selection and consumption. Then we'll look at individual equations, where we look at like things like incorporating wage, individual default intensity, risk premium, and recovery rate. So straight into it, what's the motivation behind this research? First, in the last 40 years, there's been like great improvement, especially when it comes to financial math, because math has become like an integral part of finance, and anybody who is serious in finance right now has to know a little bit of math. So now, we're going to talk about credit risk. The problem from this paper arises from the fact that there's a probability that borrowers, people who want to borrow money, and the other counterparties may default. So what do we mean by default? Default is when somebody borrows money, he doesn't want to pay. There are times that they are unwilling to pay. There are times that they actually want to pay, but they can't pay in time. Because, you know, there are things like being paying in time and, you know, being able to pay in time, or being able to also pay the particular interest rate that is required of you. So moving on, we'll talk about credit rating companies. There are two types. There are some that rate individuals, there are some that rate companies and NGOs and governments. So this is how they basically rate from AA down all the way down to C. So most people, when they see that the credit rating of the company is at least BB plus and above, that's good enough. That means it's an investment grade. An investment grade is something worthy of investing in, basically. So moving on, we go to historical data. Like I said, back in the past, people only make decisions on maybe you're going to default, or maybe we should give you this kind of interest rate based on what has been happening in the past, and I mean based off of history. But so now we're going to look at default probabilities. First, default intensity. First, there are two types of default intensity. There's the unconditional default intensity, and there's the conditional default intensity. The unconditional default intensity is like the probability that you default in 5 years looked at from time 0. So it's just the difference between the probability of default in 5 years and time 0. So that's basically that. But conditional default probabilities, which is also called the default intensity, it actually entails the unconditional default intensity conditioned to no earlier default. That means the difference of you not defaulting in the first 5 years conditioned to the fact that you never defaulted before. So moving on, we showed some examples using the table. Then what if in a scenario where, because the ones that I explained earlier were just based on years, number of years, 5 years, 10 years, 1 year. What if we want shorter time? What if somebody defaults in 5 days? What if somebody defaults in 1 month? So there's a small time dt that we're going to be considering. And so we're going to we defined all this time the default intensity as lambda, then the cumulative probability that the company will survive to time t, then the short time period dt. And we set up this formula. We take the limit of this if we do the integral and we take the limit as the t tends to 0, then we'll arrive at a good value for qt, which is the probability of default, where lambda s is the default intensity. So we also created another formula for the average default intensity. Now, Moody's, from their observation, they haven't looked at the history of like the default rates and the percentage of default over a couple of years. They came up with kind of like a something that they can use to kind of determine what the recovery rate is. Now, what is the recovery rate? We'll define recovery rate as the price of a bond or the price of any security immediately after default. Now, if a company is worth $1 million, the moment it defaults, all the debtors, they swoop in and they want to get their money back. At that point of default, the actual value that company is worth, because you have to factor in the fact that the company has debt, the actual value the company is worth is actually called the default recovery rate. So over time, some of these companies, this chart that I have here was gotten from Moody's, and they found out that in a bad year, when there's so much default, because the higher the default, the lower the recovery rate. So it's doubly bad. If there's default, then the probability that you get more money back is very low. So it's kind of like a negatively correlated chart. So that's default from historical data. What about bond prices? The default intensity from bond prices is just defined by the formula that I have below, where R is the recovery rate, expected recovery, because for the case of historical data that I showed in the table earlier, you can easily see that there are percentages. But in this, and they already have a line of best fit to explain the recovery rate. Let's say you have a 1 million, the company is worth 1 million, and the recovery rate is only 40%. So you can only get 400,000 back as the value of that company. So that's what that R stands for. What is this? The S. The S is the spread. The spread is the margin of. It's basically what you're getting. Okay, the lowest interest rate that you can get in the market is either from a low risk-free transaction. Usually treasury bills, because they are safe. They belong to the government. They usually pay you maybe 1% or 2%. Or savings accounts, they pay you 1%. But if I'm going to invest in last holdings, and it tells me I'm going to get 10%, the fact that I'm taking a risk, that's the spread I'm getting on taking the risk on his own company. So what that means is, technically I would have gotten 2% from the government. If I take 10% from him, I'm getting 8% as my spread. And it's usually measured in basis points. Basis point is from the London Interbank Exchange. It's called LIBOR. So that's where they use it for. If you have, if they say 200 basis points, it means 2% basically. So moving on, we showed an example, and this example is pretty arithmetic. It's not so difficult. If you follow it from the slide, it's pretty easy. You can see you have the corporate yield, the risk-free yield. So you can see the corporate yield is way higher than the risk-free yield. And the Excel setup there shows the difference between them. So now the expected loss, if you invest in a corporate yield, will be 8.75. I'm going on, this actually shows that in a year where the percentage of recovery is only 40%, when the percentage of recovery is only 40%, then the loss given default will be what you earned on the risk-free minus the 40% that you're going to get if the company defaults. Now, the present value of loss, what does present value mean? I know the future value. I know if there's loss in 5 years. What if I want to know it now? That's what the present value is. And how do we compute that? We get it discounted based on the rate and the number of the period where that thing defaults, and we discount back. So from that, we can get like all the present values, we add them together and we have a total as against the expected loss, and we can get the probability of default, which we represent as Q. So moving on,
Sorry, quick question.
Yeah.
Previous slide.
Okay.
The line about the 64.34 times the e.
Okay. That is
Negative or positive?
which one?
E to the power of
Yeah.
negative, right? You mean talk about the present variable?
Oh,
The present variable.
this one, right?
No,
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 no.
wait, but
Downwards.
the,
The first line from the bottom. Yeah,
this
this
one,
one.
down.
down.
Okay.
Yeah.
Right there.
Oh, it's negative.
It's
Sorry,
negative.
sorry.
Yeah, present value is negative.
Yeah, it's negative because it's a discounting
Yes.
value. It's supposed to be negative. Sorry about that.
Okay.
So, moving on, we have the probability of default. Then, in the case of historical data, from the probability of default, the relationship which we computed earlier, we found this Q as the probability of default. Then we can find the average default intensity, which is the lambda, bar lambda, at any time t. In the case of the example that we're explaining, if the year is 7, we can easily see that the default intensity is 0.11%. Now, moving on, before we go into the risk-free one, first, what is the risk-free rate? The risk-free rate is what do I get if I invest in something with zero risk, basically. Like I said, in the case of the treasury bill, if they're paying me 1%, I can't complain because at least I'm getting something. That's what risk, without taking any risk, I'm at least getting something back. So in real words, it says the risk-free rate is a return, the risk-free rate of return is the theoretical rate of return of an investment with zero risk. There's no risk, I'm not taking any risk. So, and then moving on, if I use that to calculate the spread, like I did earlier, for the case of bond prices, I'll have this. Now, in this case, what we're trying to explain here is that the real world is the historical data, while the risk neutral default probability is the default intensity gotten from bond prices. So what's the difference between them? Because we want to know, because if you look at the table, the graph that we have, the table that we had here, you will see that there's a clear difference. The ones computed from historical data and the ones computed from default intensity. Which one is better? Does this show that one is better than the other? Not really, actually, because each of them has its own use. The case of the risk neutral default probability, which is the default intensity computed from bond prices, it's actually implied from bond prices. But in the case of risk neutral, it is implied from historical data. Now, the second point is that you can use this, the real world default probability, which is the one from historical data, when you are calculating the VAR, or when you're performing a scenario analysis, which is kind of different from when you're doing value credit for derivatives or estimating the impact of default on the pricing of an instrument for bond prices. Also, there's something called the systemic risk. Now, a systemic risk is kind of like inherent risk in an economy or in an industry. Let's think about the Silicon Valley, the IT industry. Now, in the IT industry, like in the early 2000s, when there was rumor that the IT industry started having problems, when one company defaults, others start defaulting, because that is a systemic risk. It affects everybody else. When one defaults, everybody else starts defaulting. Then there's also the problem of non-systemic risk, which is that, okay, I think I can diversify away my risk, which is that, why don't I invest in IT, oil and gas, I move to petroleum, whatever, I'm splitting my risk. But the same problem is still inherent as long as we're in the same economy. There's a probability that something might go wrong